Hello the internet and welcome back to my channel. On one of my previous videos I fixed a couple of Apple IIc CRT monitors, and today on the bench we have the Apple IIc, which goes with one of those two monitors. Now this is my own Apple IIc, I purchased it for my own collection, and I'm told it doesn't work, it might have some issues with the floppy drive, but I'm not sure that's the only problem, so we'll take a look and see what works and what doesn't. Now the Apple IIc is basically a compact version of the Apple IIe I've got here, and the C indeed stands for compact. It's basically the same of an Apple IIe, but with some cards already built in out of the box. There are basically 5 cards integrated in the Apple IIc, which are 2 serial ports, 1 floppy card, the mouse card, and the 80-column memory expansion card. On top of that, there's a 5 1/4 floppy drive, which is integrated in the machine itself. So that makes the Apple IIc a very capable machine out of the box, but obviously it lacks the expandability the Apple IIe has. Now the Apple IIc runs on 19 volts. In my case, I've got a modern version of the original power supply. It's a switch and mode power supply. It's very small and very convenient. I understand the original version of the Apple IIc's power supply was a massive linear brick big transformer, which wasn't very compact and very portable, to be honest. But the idea of running the whole computer on 19 volts DC was that in theory you could run it on battery, so making this computer completely portable. This video is sponsored by PCBWay, your first stop for PCB prototyping and 3D prints. More on that later. For now, let's crack on and let's take a look at these Apple IIc. Now I feel I got all the tools I need to troubleshoot this machine, as if it's true that the floppy drive of the Apple IIc has an issue, I can test the floppy drive onto the Apple IIe, and I can also test the Apple IIe drive into the Apple IIc. Obviously it will need to be outside of the case. I also have a floppy EMU here, which is basically a modern replacement for the floppy drive for the Apple II series. So, I got plenty of options to try and troubleshoot this system if there is an issue with the floppy drive. But the first thing I'd like to do is to plug it up, connect the video signal to my computer, and see what works and what doesn't. Because honestly, I don't really know. I'm not sure what works and what doesn't on this Apple IIc. And let's try, I should have my favorite diagnostic suite, which is XPS. So let's try this one, and let's power on now. Yes, I have checked this drive. The keyboard is in horrible shape. I understand there is a rubber mat underneath. I think it was because this system was supposed to be portable. It was to prevent spillages to go into the computer. But over time, it's got deformed and probably it hardened a bit. So keys are really, really sticky and have this spongy feeling. They're absolutely horrendous. I'll have to fix that at some point. Okay, well, the drive doesn't seem to be working at all. And I'm pretty confident that disk is working, not 100% sure, but anyways. And I would say the next step would be to open this computer, and then we can try, the other drive or the floppy EMU, there's a number of things that we can try. So let's open this up before we continue. And I'm into the Apple IIc. First of all, let me show you this, which is what I was talking about the keyboards. You can see you got this rubber stuff in here, which over time it's got deformed. So when I'm pushing the keys, they're not free to go, to be honest, especially in the middle. And it feels so very spongy. So at some point I'll have to remove all the keys and basically remove these protections. Right, before I go with the modern option of the floppy EMU, I'd just be curious to try my other Apple IIe drive and see whether that works with the same floppy disk or not. Okay, well, second try. 3, 2, 1, go. Aha, so this is working, perfect. Well, let's run a memory test, as first I want to make sure the main system is okay. Oh. Well, I wasn't aware of memory issues with the system. I would say let's run the integrated test of the Apple IIc, which is done by, if I remember right, holding the 2 Apple keys here and turning it on at the same time. Ah, okay, yeah. Apparently there is a RAM issue with this system, so I guess we have to solve the RAM problem first. I need to find out which one of the memory chip is the first one in the line. So let me double check on the service manual. Right, so I think I found something about the meaning of this error code. So basically the Apple IIc has 128 kilobytes of RAM, 64 kilobytes is the main RAM, and 64 kilobytes is the auxiliary RAM, which on an Apple IIe would be on a separate card. But in this case, it's all on the same motherboard. The understanding here is whenever there's an issue on the main RAM, it just says RAM. Whenever there's an issue on the extended RAM, the auxiliary RAM, it's going to be asterisk RAM. Now we're getting RAM here, so it means that we have an issue with the main RAM, which is kind of weird that, the software is even running with an issue on the main RAM, but anyways, that's what the self-test says. And according to this manual, the module on the right-hand side, this number here on the right-hand side, is the one closer to the keyboard. So because we have a number 1 here on the left-hand side, it's going to be the 8th module from the keyboard towards the back. So I would say, let's take a look at that. So first of all, this is the MT. I don't know, I can't remember what MT stands for, but that's the one that always fails, if I'm not mistaken. Anyway, as you can see, we've got these MRD0, I think it's main RAM, something like that. Because up here we got AR, which I'm assuming it's auxiliary RAM something. So according to the instruction manual, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. There's going to be this module here, which I'm going to mark with this marker here. Before just replacing it blindly, I'd like to play with it and see whether I can spot anything. And the first test I'd like to do is to turn on this computer and just test the temperature of the chip itself. The computer is on. Let's see if anything is warmer than the other. And no, nothing feels out of the ordinary. Okay, let's fire up the scope and take a look at those lines then. So let's have a look at this. So that's going to be our input, and that looks totally fine. After that, we have write enable, which looks fine. We have RAS, which looks fine. Then we have 3 address lines, 80, A2, and A1, and they look perfectly healthy. Then we have VCC, 5 volts. And on the other side, we have more address lines. So this is A7, that's fine. A5 looks fine. A4 looks fine, A3 looks fine, and A6 looks fine. Then we have Q, which is our data out, and that looks fine, and CAS, which also looks fine. So I don't see anything suspicious looking at that. So if there is something wrong, it's probably the chip returning the incorrect value, and that's not something that I can see with an oscilloscope. It's something the software is checking for me. Now, one thing I've noticed is this: if I reset the computer into diagnostic mode, Q, which is data out, is high, while if I'm checking other modules, there's something going on with them. All the other modules are doing something, while again the affected one is kept high. And the same with data in, which is this one, is always high, but if I compare it with other modules, there's stuff going on. I'm assuming this is the diagnostic routine, basically saying, okay, I'm not going to use this IC for whatever reason, because again, using XPS, everything looks totally healthy. Well, the test was inconclusive, but that's fine. It was just an opportunity to see if there was anything to learn here. So let's move on. Remove that RAM chip, install a socket, and a shiny new IC on it. And I'm ready to give this another go. So 3, 2, 1, go. Okay, well, it's booting up, which is a good sign. And let's try the memory test again. We don't have issues anymore. It's still testing, hasn't passed anything for yet, but there's no error messages. Yay, pass 1. Fantastic. So that seems to be working, it's great. I would like to try the built-in test again by holding the 2 Apple keys and turning on. And it passed. Great. It's a system okay. That's great. So we fixed that. I would say now we can have a look whether the floppy drive is working or not. I don't think I'm going to need custom PCBs for this project, but if I did, I would recommend PCBWay, the sponsor of this video. You've seen me using PCBWay PCBs in the past, like these beautiful XT80E I built for my PS2 project, and I've never been disappointed with the manufacturing quality. So thank you PCBWay for helping the channel. Okay, right, I've got the floppy connected to the Apple IIc. I just found a longer cable, and I've got the XPS testing suite in the drive itself. Let's see if it even runs, and if it does, we'll try and run some tests. So power up in 3, 2, 1, go. Okay, well, it is working. I got to say that off camera, I tested this setup just before starting the camera, and it wouldn't work. It wouldn't load anything, and then after a couple of tests, it started loading, so it's a bit weird. But that being said, let's try and run some tests. First of all, I think I'd like to run the speed test. I know that HPS is not the best in terms of speed, but it will tell me whether the speed is roughly there or not. I'm not sure what's going on here. It says put test disk in test drive and press any key, but when I do it, it just sticks to track 0. And then it doesn't do anything. That's interesting. Well, let's try the disk system, which is G. It's doing a comprehensive read-write testing. That's weird. It doesn't even try. It doesn't come up with an error message or anything. It just says the disk is not in. Hey, this is Future Tony. I had forgotten I bypassed the write protect switch on my Apple IIe drives, so I never noticed that error before because the 2E thinks the floppy is writable. What the 2C is telling me here is simply, hey, this floppy is write protected, please insert a writable one. So there's nothing wrong with this behavior, but it helps spotting a potential issue on the next section. Now, there is something I've noticed, I'm not sure whether that's supposed to happen or not, I would say no, and is that whenever the head moves, the speed of the drive seems to change. Now, it's incredibly difficult to show you on camera. I think I can see that with the stroboscopic light pointed at the pattern here. The thing is, it's impossible to show on camera, number 1, because it's the mobile I'm using to shoot this footage. Number 2, because this is shot at 30 frames per second, this is 50, and then you have your home frame rate on your monitor, YouTube in the middle. You will never see that happening, I think. But I think I might have found a kind of a workaround to show you what happens. So I'm gonna use this. I know this sounds weird, but what I'm gonna do, I'm gonna point one end of these plastic pipe to where the stepper motor for the spindle is, and I'll stick my microphone in the other end, and hopefully you hear what I'm hearing here with the, with my ears. Let me see if I can show you. So I think I managed to capture the noise, and I can assure you that that's not the stepper motor for the head. That's actually the stepper motor for the spindle, which is making that noise. Now, if I remove the belt, the spindle is completely free to spin. There's no friction whatsoever, so this doesn't feel like a mechanical thing. Now, I believe this little board here is the one controlling the speed, well, controlling the stepper motor itself and the speed of the motor. So I think the next thing I'd like to do is to probe the output of this thing and see if I can see anything changing, see if I can back up my theory that the speed is changing when the head is moving. I've got the oscilloscope connected to the yellow wire going to the spindle stepper motor. I'm basically monitoring the motor itself. Being a stepper motor, I'd expect some pulses here. Now the drive is just spinning, it's not doing anything, and I see these pulses on screen. The scope says 360 Hz and the signal is pretty much stable here. What I'm going to do now is to load a game which will trigger head movement, and we'll see if there are any changes. Okay, I'm about to restart the computer. And yes, the signal is not stable anymore. It looks like the frequency of the signal is getting higher, which I guess it might represent a faster speed. That's interesting. I'm not sure about this test, so let me do the same test but with the Apple IIe drive and see what that does. Okay, same setup and the drives are basically identical, so I'm testing the same yellow wire. The same game is in and I'm starting the computer now. No, it's doing the same. So maybe that's not what I'm looking for. Well, I would say for now, let's consider this issue I found a false alarm. Let's consider that completely normal. So I think the next step I'd like to do, just before I get deeper into diagnosing this thing, is to try the Apple IIc drive into my Apple IIe and see whether it's working totally fine. And the Apple IIe is plugged in. I got Karateka in the drive. So let's power up and see if it works. 3, 2, 1, go. Yes, it is. It's loading fine. Maybe I was probing the wrong part, because I just tested with the plastic hose and I don't hear the spindle changing speed. This is very weird, because I clearly hear the spindle changing its speed whenever I use whenever I'm listening to it, basically. But with the Apple IIe, that doesn't seem to be happening. Let me see if I can show you. So I think it's pretty clear that there is an issue with the speed of the drive, but with the Apple IIc and not with the Apple IIe. I'm wondering whether the Apple IIc has a power supply issue. So I got the Apple IIe connected and I'm monitoring the supply voltage coming to this little board, which is driving the stepper motor, driving the spindle itself. So first thing I want to do is, let's see what kind of voltage we're getting here and whether there is any instability when the rest of the drive is working. So if I power up the Apple IIe now, so we're talking about 12 volts-ish. And as you can see, the voltage is dropping a bit whenever the head is moving and whenever the spindle is moving as well. So this is with the spindle not running. So again, the computer is not doing anything. Let's try and measure what happens when, what's the difference, what's the delta in voltage when the head is moving. So if I let it run again, yeah, I can measure it from here. Yeah, we're talking about half a volt, more or less. So you can see that between the drive not doing anything and the head moving around, it's about half a volt. You can see that it says delta Y, it's 0.5 volts. So it's not much, okay? Now, let's try and do the same with the Apple IIc. Apple IIc is back in. I haven't touched the oscilloscope, so we get the same scale, the same resolution on the screen. And let's power up in 3, 2, 1, go. Oh, wow. Oh, wow, okay. Oh, that's a big difference. So let's wait for the drive to stop. So do we have the 12 volts? We do have the 12 volts. So it's a bit dirtier, but most importantly, so that's my 12 volts. And if I run the drive, well, it's going down to 10 volts, even less. I can see 9 something. I guess that's why that's why the drive is slowing down. That's very interesting. So we got 2.38 volts of delta whenever the head is being run, and I don't think that's a normal thing, to be honest. So it looks like this computer has a supply issue. It's actually dropping to a pretty low value here. I mean, it's dropping down to 8.7 volts, so there's almost 4 volts difference between the nominal 12 volts and where it goes when the head is moving. I guess no wonder that drive is having difficulties. So at this point, I think I would like to take a look at the power supply section of this computer. So the way the Apple IIc works, as I said in my intro, is it works with 19 volts DC. It's coming through this connector here, through the transformer, and it's going into this little box, which is actually removable. So we're basically getting 19 volts coming here, going through the main switch, and the 19 volts is reaching this little box through this connector here, going into the box and coming out processed. So we will have a number of different voltages coming out of it. Now, as I said, the external power supply I'm using is delivering 19 volts DC. Now, I believe the original brick would deliver 15 volts unregulated. However, the Apple IIc technical manual says that this converter accepts voltages between 9 and 20 volts, so I'm within specs here. Now that being said, the first thing I want to do is make sure that this voltage issue is not actually coming from the power supply itself. So what I'm going to do, I'm going to power up the computer, let it load Karateka as it was doing before, and checking with my scope whether there's any voltage drop when the drive is working. And now, as you can see, there's no issues whatsoever. The 19 volts coming into the computer is perfectly stable. So the next step would be to check the 12 volts out of the power supply, which, to be honest, I'm assuming is the same that I was measuring on the drive. But I'd like to measure here on this connector here, which is the output of the power supply. So let me find where the pin is. Okay, I got pin 38 connected to the scope, so let's power up and see what it reads. 3, 2, 1, go. Aha, yes, and that's the 12 volts line, and it's showing exactly the same issue. So it's going down to 8 point some volts here, and obviously I don't think that can be acceptable, to be honest. Now, if I'm looking at the schematics, 12 volts, it's only used on this computer by the internal drive, the external drive, and the 2 serial chips. These are the serial chips. They're not hot, so it looks like there's no short in here. That's the integrated watts machine, which is the drive controller. It's not hot at all. I'd like to take a look at this power supply, actually this DC to DC converter, because it might be that there is something wrong with this. Now, if I'm looking at the schematics, the 12 volts is coming out of this leg of the output, that's the switch and transformer, and there's only one diode, one resistor, one capacitor, and then there's an inductor. So there's not much. And from the same transformer, from the same coil, let's call it that way, you also have 4.9 volts coming out. So before moving any further, I'd like to check whether the 4.9 volts also has the same issue, because I guess that might help pinpointing the issue, whether it's on this side of the converter, let's call it that way, or on the other side. So yeah, let me plug this back in. It's open, but it's totally fine. And again, this is not mains, it's only a 19 volts to whatever, so it's kind of safe. And I'm connected to the, let's call it 5 volts line, and let's see what it does. 3, 2, 1, go. Okay, that's interesting. Karateka started and I didn't see any issues whatsoever. It's very stable. So to be honest, I would say I'd like to check this capacitor here. It's a C9 330 microfarad, and C9 is this little fella here, so there's no issues here. I don't see any issues on this end of the capacitor. I guess I'll have to remove it, which is kind of easy because the back of the board is accessible, and we'll measure it and see what the instrument says. Well, I'm not sure I see anything. I might see something, maybe not here, but at the bottom of the board. There is a little ring of something where the capacitor used to be, which could be production something, or it could be juice that leaked over time. So let's test it. Well, it's taken a long time. And would you look at that? It looks like this capacitor is actually faulty. Perfect. So let me see if I have a spare. We'll go ahead and replace it. And here is my spare. It's a 330 microfarad 16 volts from Nikon, and this is actually the PW series, which is designed basically for power supplies. It's nice to see how the technology evolved, because these are more or less identical capacitors, but obviously the new one is much smaller. The original capacitor is also 105 degrees as my replacement. It's gonna fit totally fine, and hopefully that will sort out our 12 volts line problem. And I'm back monitoring the 12 volts line with the converter back in place. So let's power it up in 3, 2, 1, go. Aha. Yeah, it's still doing something, but I would say it's so much better. Let's take a look. It's definitely much better, because as you can see, this is going down. I would say it's probably going down 1 volt, which is a bit too much, but it's only for a split second, and then it goes back up to minus 0.7 volts compared to where it was. So it is so much better than it was before. So definitely the capacitor had its own little responsibility there. Now, one thing I'm noticing here on the schematics, there is another 12 volts. It's not an output, this is inside the power supply. I don't understand where it's going, to be honest, but I see there is another capacitor which more or less it's on the same line. I mean, it doesn't matter whether it's here or here, it's still on the 12 volts line. So maybe I should check this capacitors as well, which is C16. Let's go and take a look. And this looks totally fine, the value is correct, the ESR is very low. That being said, because the 12 volts line was having issues and it still feels a bit weaker than the Apple IIe, I'll go ahead and replace it anyways. And for this capacitor I have a FR series from Panasonic, 105 degrees, 220, 16 volts. Okay, replacement capacitor is in, ready to test in 3, 2, 1, go. And no, I think it's unchanged. But honestly, it's very similar to what I get from the 2E, and it's so much better than it was before. So I think the supply issue is resolved. Okay, time to focus on the floppy drive. I'm using my Apple IIe simply because it's easier for me to probe signals here on the disk drive card if I needed to, rather than on the Apple IIc. But the drives, the one from the Apple IIc and the one from the Apple IIe, they are basically the same thing and they are interchangeable. This drive is being, let's say, a bit temperamental, so it's not easy to diagnose things and also to explain things on a video without wasting so much time. The thing is, the drive is working now. I got Karateka inside the drive, so let me see if I can run it. As you can see, Karateka starts totally fine, there's no issues. So that works totally fine, no issues, no hesitation or anything, and it works absolutely fine. Now the other thing is diagnostics, so let me try again XPS diagnostic. It's kind of my favorite diagnostic for the Apple II series. So there's a very nice comprehensive list, I like it, disk system test, which is G here, and if I run it, well, yes, I'll need a writable disk inside. As you can see, I've got speed errors, which is kind of understandable with XPS. I think XPS, unless it's 300 on the dot, it will come up with a speed error more or less. But I also have write errors. The thing is, it's actually doing something, which is a good thing, but it's got this speed and write error. So let's go back and let's check the speed of this drive. And, and this is very weird. This is very weird because I'm getting 583.1 RPM. Now, I can assure you that this drive is not running at 583 for two reasons. Well, number one, you won't be able to see this on camera, but I can see the 50 Hertz pattern here, which is not moving or moving slightly. So it might not be 300, it might be 290 something, 300 and something, but definitely not twice the speed. The other thing is, again, I have a tachometer, and if I'm checking now, you can see I got 299, 300. It's around 300, it's not 600. So to progress with the diagnosis, I thought maybe I should look into this speed error. Why is the drive reporting a complete different speed that I'm actually measuring on the drive? And again, the drive is working, it would not work, it would not read at 600 RPM. So I thought I'd like to find out how the drive is actually reading the speed. And I went and looked at schematics, and there is a story behind this drive, which is the genius of Steve Wozniak. So when the system was developed, Steve Wozniak came up with this very simple to build and very inexpensive drives. If you compare them to the Commodore 64 floppy drives, they actually had a 6502 inside. They had a ROM. I can't remember whether they had any RAM. I don't think so. It was basically a small microcomputer within the floppy drive. It came with power supply. It was a massive thing. It was super expensive, and the computer talked to the drive via serial. So the drive needed to be able to process information in order to talk to the computer. Now, there's nothing like that with the Wozniak drives. This drive is very, very dumb. Is the computer itself basically driving the floppy drive, the disk drive, 100%. Even the head is controlled by the CPU itself, if my understanding is correct. So I was looking at the schematics and I was looking for some, I don't know, maybe index pulse or anything that could basically tell the system how the speed is behaving on the drive itself. This is the speed control. It's actually the driver of the spindle itself, and this is where you set the speed of the drive itself. Now the thing is, if I'm looking at the schematics, this is completely detached from the computer. The computer doesn't know what happens here. There's only an enable pin coming here on this connector, which is basically telling the spindle turn on, turn off. That's it. There's no feedback coming back to the computer. Now, if you remember my PS2 drive, there was a magnet on the spindle itself. So the computer in theory could actually read the signal, which was the index pulse, which was actually missing on the drive. And it could probably ascertain the speed of the floppy from that signal. So here on the schematics, I was looking for some kind of pulsing coming back, but there's really nothing. I have data being read, data being written, then I have write request, which I guess is when the computer tells the drive, well, I'm sending you data, please enable your write head. Then we have the notch detach, then write protect, which is more or less the same thing, but basically that's the sensor reading the little notch here when basically the drive becomes writable. And there's not much else. Again, there's this enable signal, which is basically turning on the motor itself. Then you have the signals coming from the interface board, which is literally the signals going to the head, so the head can be moved to the right position. It's the computer itself moving the head. It's not the computer telling the drive go to that position. There's no logic to do that on the drive itself. Then on this part of the schematic you have the speed control board, and as you can see from the speed control board, it's only the enable pin coming in and voltages coming in. And finally you have all the voltages, plus 12, minus 12, plus 5. That's it. There's really nothing else. So what I thought was, for the computer to ascertain what the speed is of the drive itself, it's probably reading something from the disk, and that would explain why when I'm inserting a floppy drive for testing the speed, the software or some software is telling me, well, the drive is going to be written to. And I think the way it works, that's my very guesswork here, is the drive is writing something on a track, and then it's just reading how many times it comes back, it reads back. So the computer can basically do a basic calculation and calculate the revolutions per minute. Now, if that is the case, and also considering that XPS is telling me the writing has an error, I'm thinking, what if the drive is having an issue writing data on it? Because it can definitely read, because I've been reading stuff, I've been booting from it and running software from it, so that's totally fine. So I'd like to run a quick writing test, and I'm a bit rusty when it comes to Apple II software, but I'd like to try this. Okay, I'm in BASIC here. What I'd like to do, I just would like to write a simple BASIC program and save it onto disk and see whether it saves, restart the computer, load it back and see, making sure that it's actually working. So I'm going to write something new here. So let's start with with clearing up the memory, and I'll write the usual suspect, the usual very short basic software. There it is. So if I run it, I have the usual thing, the usual simple thing. If I save this, the drive is working. I can see the head is moving. There's no error. And let's see if it's actually saved. So then we can try maybe and restart the computer and see what happened. Oh, that's it. It didn't save. It's just gone. Okay, well, that could be the problem with this drive, that it's not writing. And that's why the speed test is also failing, because it's not writing the correct pattern. Now, because as I said, I'm a bit rusty with Apple II, I'd like to do the same with the other drive and make sure that, my theory is correct and actually everything works. Let's make sure that the Tony359 file is not here, I don't see here, and definitely is not there. Okay, so yeah, let's start another one and let's write the same thing. Okay, this is working, and now I'm gonna save it on the drive. Okay, the drive, did something. And let's check now if the file is actually on the drive. It is, right, okay, so yeah, it looks like the drive has an issue writing something, so let's follow that lead, basically. Okay, well, now that we know that we might have an issue with the writing, I would say let's try and use the oscilloscope and see if we can see what happens, see where the signal is stopping, whether there's something reaching the drive, getting into the signal amplifier and so on. Now, if I'm looking at the schematics, it's pretty simple, to be honest. This is the head, the read-write head, and there's also an erasing head, which I didn't know existed, to be honest. So the same head is basically used for reading and writing, not at the same time. So either the disk is writing or the disk is reading. Here on the right, you see there's a read amplifier and there's a write amplifier. The read amplifier is basically getting the signal input on these pins here, 16 and 17. Then it's connected to pin 1 and 2 to the heads. And the writing amplifier is connected to the same pins. Well, it's pin 1 and 5 on the IC, but it's connected to the same parts of the heads, and it's getting this input here where it says 2, which is basically the write data pin. You see here, write data, it comes through some logic. I think this is when the write request is also enabled. It's basically only if write request is active, only if the notch is removed from the disk, because that's the notch detect, then the write data is going through and is going to the write amplifier, which enables the output and basically energizes the heads. And the write amplifier is also energizing this transistor, which is basically sending 11 volts to the erasing head to erase data. The first thing I'd like to do is, we know this drive is reading, so let's probe this test point 1, which is read data. That would be data coming out of the drive to the computer. So we know that works, so at least I can make sure that the oscilloscope is working and my setup is okay. So what I'm going to do now, I'm going to test on test point 1, and this is the read data coming out of the drive, and as you can see, it looks totally fine, which is expected because obviously the drive is working, is putting stuff. So the next thing would be to see whether there is write data going into the write amplifier. So I would go straight to pin 2, to be honest, and see whether there is something on it. This is the CA3146. And yes, it only happens for a brief moment, but there's something going to the IC somehow. So I would say at this point, I'd like to check whether there is something coming out of the IC into the coils. And for that, I'm going to check pins 1 and 5 of the same IC, which is basically like checking the coils themselves, because then you have this one in the middle is basically grounded through a resistor and a capacitor. So let's check on pin 1 and 5 and see if there's something coming out of the write amplifier. This is pin 1, nothing at all. Let's check pin 5. I'm on pin 5 now. And there's absolutely nothing. Well, that could be our problem. Now, I can see the amplifier is also getting other signals. Obviously, it needs the write request as well in order to function. And I can see the write request is going to a number of pins. And let's check pin 4 to make sure there is a signal going to the IC. And yes, it's very obvious in roll mode, there is a clear write request signal going into the write amplifier. Before going on and blame the writing amplifier, we have an Apple IIe drive which is working, so I would say let's plug it up and try and do the same measurement on that one to see whether my measurements make any sense. Okay, so I'm with the Apple II drive and I've got XPS running already. So on the same IC, the writing amplifier, let's probe pin number 1, which is the output basically. Oh yeah, there is definitely an output, and I think the other one was number 5. Yeah, same thing. So this looks like the confirmation that my Apple IIc is not writing, and it looks like the signal is reaching the IC but it's not coming out of the IC. I would say let's swap the IC, because this one of the Apple IIe, it's a different brand but it's exactly the same IC, so I'd like to do that. Right, the replacement IC is in the drive, so let's power up. 3, 2, 1, go. And I'm back on pin 1 of this IC. Yay, we got output this time, look at that. It's a bit off screen, but there's definitely output this time. Amazing! And if you look at SPS, there's not write errors anymore. Look at that, we got speed errors, so I would say let's test the speed and see if we are still getting the silly number. Yay, 295, it's working! That was it, it was just the write head amplifier. 295 is on the slow side, so let's adjust it to something like 298 real quick. Okay, we are at 299 basically, so that should be totally fine. And I'm assuming that now XPS is going to be happy with the speed test as well. Yeah, got 3 passes, no errors whatsoever, no reading, no writing, and not speed errors. Amazing. Now, as a final test for this drive, I'd like to use the mech diagnostic as well, because that was failing as well without saying much, to be honest. So let's check the speed with this one. That was failing as well before. Yeah, and it's reading totally fine, 298, which is what I left with the other one. Perfect. Let's try general operation, which again was failing again. And it's working. Perfect. Wow, okay, that's very rewarding. having been looking into the schematics for a while and, getting to the right IC first thing first, because it's always easy to just start replacing parts. I have another drive with, basically it's identical, it's just a bit bigger. It would have been easier to just swap the IC. It's that both socketed. I could have done that first thing first. What's the fun in doing that? Yeah, you fixed it, you move to the next project. You don't really know what you've done, you just swap the chip. Well, I would say let's reassemble the Apple IIc, because I think this is done, to be honest. This drive is in very good shape, so no major cleaning is required. I'll just go with the usual. Clean the rails and lubricate them. Plus a good clean of the spindle, the motor pulley and the belt. And it's back together. I would say it's time to test this thing. So let's run a quick diagnostic again to make sure that everything is in order. And then I guess we can just close it and call it a day. Oop. Well, I heard something whining as there was a short. That's not great. Yeah, it's definitely not, the green light is not coming up. It's definitely something shorted. Well, I guess I'll have to double check that. I might have found a problem, which I didn't realize. That new memory module is just under the floppy drive, and I don't think there's enough clearance for a socket. It's difficult to see on camera, but it looks like it's probably touching on the drive. Right, just to double check, I got the meter in continuity mode, and it's connected to ground at the moment here on the left, bottom left. And if I'm checking against the 5 volts supply of this chip, which is pin 8, that's it, it's not really a short. But if I'm pushing down on the drive, it goes down to a dead short. So yeah, I'm basically shorting the 5 volts line to ground when the drive is in place. Unfortunately, my only option is just to solder the IC straight to the board. Right, I've just realized I should have tested that memory chip without the short before permanently installing it on the board, because if now things are not working, well, the first thing I'd like to try is just to swap the memory chip. Well, it's too late now. Let's try and see if it works now. If it does, I'll go ahead and reassemble it. In 3, 2, 1, go. Well, it beeps. And there is an output. Okay, that's great. There's no keyboard, so obviously it's not doing anything, but it is working. So, whew, it's I was lucky this time, didn't damage anything. Let's now put it back together. And it's done, take 2. So let's try this again, and let's hope that this time it works. 3, 2, 1, go. Yay! Oh gosh, I'm really lucky today. Okay, let's try XPS again. And I would say let's run a quick drive test. Well, I've got speed errors, but I'm used to seeing them with XPS, as my drives are usually set to around 298 RPMs, and I believe XPS starts giving errors just below that number. But let's check the speed real quick. Okay, it's 297.6. It's on the slow side, but it'll do for now. What matters is that there are no other errors anymore. To just double check, let me do the basic test again. Well, first, let's delete the file I saved before. Well, and that worked, by the way, which is a good sign, because the erase head is driven by the right amplifier IC. At this point, I ran out of space on my camera, so I stopped and resumed the following day. But before re-recording the final tests, I decided to take a look at some squeaky noise coming from the drive. It was the usual center hub noise. I put some lubricant in it, which did not fix the noise, so I started disassembling the faceplate to remove the hub. I decided not to record it, as I thought it was boring to watch. I then put the drive back together and, well, the drive is dead. It spins and the head seeks to track 0, but that's it. I cannot boot anything anymore. And for the life of me, I cannot think of what I can possibly have done to cause this. But I've tried everything I could think of, and it still doesn't work. I only removed the faceplate and the hub. I'm confident the hub is reassembled correctly, and everything seems to check out. So, I'm lost here. Right, I think I'll pause the video here, because otherwise the video gets too long. That was totally unexpected, but in the next video we're gonna pick up from here, take a look at that new fold, and see if by the end of the video we can have, finally, a fully working Apple IIc. Meanwhile, if you like this video, you know what to do. Please hit the like button down below, and also come back and watch more videos and subscribe to this channel if you like this kind of things. I hope to see you again soon for the continuation of this video. For now, thanks for watching, have a great day, and goodbye. Bye.